Hi everyone. In today's session, we will discuss our Unit 2 shear force and bending moment diagram. In the first topic, beams and the types of loading, and what do you mean by shear force and bending moment diagram, and point of contraflexion, and simply supported beam with point load. So, first, what do you mean by a beam? A beam is a heavy, long structure which is used to carry the loads, and mostly it is used in construction space. So the beams are classified as cantilever beam, simply supported beam, overhanging beam, fixed beam, and continuous beams. So first we shall go with cantilever. Cantilever beams are nothing but one end of the beams are fixed and the other ends are open or free. So type of beams are said to be cantilever beam. Here you can see the pictorial representation of a cantilever beam. And next is a simply supported beam which carries both ends of the beam are supported vertically or both vertical and horizontal directions also. And next is overhanging beam. For entire length of the structure, the beam is supported between the centers. So here is the structure. And next is continuous. For every particular distance, if you are carrying a supporting member, then it is called as a continuous beam. And next is fixed beams. If both the ends of the long structure is fixed, then it is called the fixed beams. Okay. Are you clear with what do you mean by beam and what are the different types of beam? So next, what do you mean by load and what are the different types of loads are acting on a beam? So a load is nothing but a mass or a weight supported for something. So types of loads are, first one is point or concentrated load, and second is uniformly distributed load, and the third is uniformly varying load. So first we shall discuss with point or concentrated load. In the name itself, it is mentioned as point, which means at a particular point, if the load is acting like this, if the length of the beam is some 3 meters, at a particular 1 meter length, there will be some load W1. Only at that particular point, if the load is acting, that is called as a point or a concentrated load. Next, uniformly distributed load. So in the name, the distribution of load is uniform over the entire beam. If you see the screen, the load is uniform at every particular point, and this is indicated with W Newton per meter. So for particular meter, if the beam is 5 meters, then the load is load of 2 kilonewtons for a 5 meters length. So 2 into 5, 10 kilonewtons will be acting on the beam. And next is uniformly varying. So from initial to end stage, if the load is varying gradually, then it is said to be a uniform varying load beams. So uniform varying load. So I hope everyone is clear with different types of loadings. So next we shall discuss about what we mean by a shear force diagram and a bending moment diagram. So whenever you are applying a load on a beam, so the algebraic sum of all the forces acting on the beam is nothing but the shear force diagram. I will go with a better example in the next further slides. So if a beam is having a 5 meters length and at every particular 1 meter length you are acting some 2 kilonewtons. If you take the algebraic sum of all the forces acting on either direction, either in the upwards to downwards or downwards to upwards, then the sum of all those forces is nothing but shear force diagram. And next is bending moment diagram. If the algebraic sum of all the moments, you all know that moment means force into particular perpendicular distance. If you take all the algebraic sum of all the moments of forces acting on either side of the section, then it is called as a bending moment diagram. One important point we have to remember is point of contraflexure. That is nothing but where the curvature signature changes, either from negative to positive or positive to negative. The particular point where the sign changes takes place is nothing but the point of contraflexure. Okay, this particular. So now I'll go with different types of loading with beams and how to draw the shear force and bending moment diagram. So now I'll write first. I'll go with cantilever beam with point loaded free end. We all know that cantilever beam is nothing but one end of the beam is fixed, and at the other end he is mentioning is a free point load. So one end of the beam is fixed and the other end is free. So that is called as a cantilever beam. And at the end, free end, we are having a point load of W. And the total distance from free end to fixed end is that will be X. So here the particular, you draw a baseline reference line from 0. Here the beam is fixed, so it is will be 0. But at the position X, that load is some W will be acting from vertical. So if it is 2 kilonewtons, it will be heighting a height of 2. So, but it is constant till this point. So we'll write a horizontal line and hatch it. So we all know that bending moment means force into perpendicular distance. So what is the force acting here? W, and the perpendicular distance will be W into L. Initially it is 0. So W into L. So it will be triangle. And as it is below acting downwards, so the BM bending moment diagram will be in negative side. I hope everyone is clear. And now we go with same point load at center for a simply supported beam. We know that simply supported means both ends are supported in this diagram, and the load is acting at center, which means the total length of beam is L, half phi of L by 2 L by 2. So here the shear force, first we have to find the reaction forces at both the ends, A, B. How we will be finding means reaction forces RA plus RB is equal to, so these are supporting from downwards to upwards. So the upward force is W. On finding this one end is fixed, and we are finding the RA and RB. Okay. So initially here the point. So at this point the chain will be changed. This point is called as point of contraflexure. And here the beam starts with both ends, it will be 0 always. At the center it is force into perpendicular distance. Suppose 2 kilonewtons and the length is 3 meters. 2 into 3 is 6. So here the point is 6. So draw a line. Okay. This is how you are drawing the shear force and bending moment diagram. Now we'll go with the cantilever beam with UDL and simply supported. The same diagrams will be very helpful. So in the class, we'll practice n number of problems, and in the result some short answer questions and essays asked in your university examinations. Thank you.